Let's look at some bond angles in two different molecules. How does the bond angle, that is the C1-C2 oxygen bond angle, carbon 1, carbon 2 oxygen, so this bond angle here, how does that change during this oxidation reaction? Well, looking at it here, it looks like those angles are both 90 degrees, and of course that's just because we've drawn them straight out on paper. In order to determine the actual bond angle, you have to go to a good Lewis dot structure, get steric numbers, and go to the molecular geometry. We can actually do that. So about the carbon in question, I've drawn the appropriate Lewis dot structure. I haven't drawn the full Lewis dot structure, but I've drawn the full one and then taken just the important part. That allows me to determine the steric number around this carbon and this carbon. So the steric number here around this carbon, 1, 2, 3, 4. That carbon has to accommodate 4 things. This carbon has to accommodate 1, 2, 3 things. Now again, it's not the number of bonds, it's the number of things bonded to that carbon. An oxygen, a hydrogen, and a carbon. This has 2 hydrogens, an oxygen, and a carbon. Steric number 4 here, so the bond angle is going to be tetrahedral. There's going to be tetrahedral orientation around this carbon, a bond angle of 109 degrees, and this carbon here, steric number 3, a bond angle of 120. So the bond angle increases as I do that oxidation.